This is an interesting problem. Having taught this area before, when I was first looking at this, it kind of threw me for a loop because I know where this goes when we talk about rotations of solids. But I had to kind of reorient myself because this book approaches things a little differently. What we're talking about is if this shape, if you had cross-sectional areas that are squares, and I'm trying to think of a way to represent this graphically. And I think the best way to do is if I were to kind of cut along here, cut along like right here, and split this into two different shapes. I would have this shape, this triangle shape, and then I have this rectangle shape. Now the rectangle shape, I think, is easier to show this because it's a constant shape, meaning this width here is a constant. And so what they're after is that, you know, the width is the same as the height. So you'd have these, and this is not coming out very well. I apologize. Let me get rid of some of that. Let's try this again. I'm able to go this direction. So this width, and by the way, that at that point it's 12 from here to here. So this 12 here would be the same as the height of 12. And then, you know, this, you know, my three-dimensional drawing, it worked well when I drew this on paper, but I'm just not getting it across on this screen. So let me give it one more shot. So I'm trying to give a three-dimensional perspective, and that's always a struggle. So let's see, if we went like here, 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 and here. And so knowing that this part is 12, the height would also be 12. So I'm going to cut it across like that. There, there, there. So that's that piece. I'm sorry it doesn't look any better, but people hired me for my math skills, not my drawing skills. I apologize. So then we have, so we're looking at this rectangular prism. We have, this is 3 across by 12 by 12. So 3 times 12 times 12 is 432. So that's part of it. Now we need to look at this region. Now what's different about this is if we think about cross-sectional areas and even just these cross sections, these are varying. So this is the variable part, and we have to come up with a formula for it. And knowing it goes from 0 to 4 on the x, and then 0 to 6. I mean, if we think about what is this here, 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 and here, what we're really seeing is when it gets to the biggest, that's 12 across. At this point, it's what? It's oh, it's not on a nice number, is it? At 2, it's a nice number. It's 6 across. So we're really seeing that this is y equals. When I first did, I just looked at this line here and I say, okay, it's going up 6 over 4, so it's a slope of 3 halves. So y equals 3 halves x. But then that's only for the upper half. I multiply it by 2 to get the lower half. So I get 3x. And that describes this cross section. So when I'm looking at, I'm going to move this up a little bit. When I'm looking at this, I have this cross part is 3x. But now I need the upper part, you know, the height. Well, the height's the same as the cross because it's a square. So it's also going to be 3x for any given square. And these squares get bigger as you go back. It's bigger. And this is even bigger. So that's a growing square. It kind of goes to a fine point at the end there. So it's a matter of, and we can come up with that pretty easy. So the volume is going to be length times width times height. And I don't know what you want to call width. If we call this part the width, that's a 3x. If we call the height is also a 3x, it's because it's the same. It's a square. And the length is going to be this other part that we just don't know, that we have to come up with. That's the part that's varying. And you wouldn't want to go by every 1, every 0.5, or every 0.1, or 0.01, or 0.001. We have this tool called calculus now, so we can do an infinite one. And so we're going to do an integral from 0 to 4. Let me scroll this up a little bit. Of this 3x times 3x is 9x squared. So that gives me the width and the height, and the length would be the dx. That's the part we're integrating. And so we end up with a 9x cubed over 3, which is, oh, and I'm sorry, I'm forgetting my manners here, from 0 to 4. So that's going to be 3x cubed from 0 to 4. So it's 3 times 4 cubed, that is a 4, minus 3 times 0 cubed. So it's going to be 3 times 64, which is 192. So we take that part, the 192, and we add it to the 432, and we get 624. And that's our answer. And I'm sorry for writing everything in red. I really like blue, but for some reason I went red. Okay, hope that helps. And I'll probably see some of you in office hours. Okay, thanks.